Hello, monkeys. I am back again. I had a 5 day hiatus because I was being lazy, but it's not over. I'm back, okay? It's time to do the hardest problem that I have done up till this point on LeetCode. Reverse linked list 2. Let's get right into it. Given the head of a singly linked list and two integers left and right, where left is less than or equal to right, reverse the nodes of the list from position left to position right and return the reversed list. Okay, so in example 1 here, we're given the linked list 1, 2, 3, 4, 5, and we are given that left is equal to and right is equal to 4. So if left is equal to, then we want to reverse from node 2 here to node 4, right? These are the nodes that we want to reverse. They are highlighted in a pastel blue, kind of, okay? And you can see in the output, those nodes are indeed reversed here. We have 4, 3, 2, and that's how we get our output. But the nodes around this area are left untouched. Okay, so like what's actually going on here and how do we solve this? Just to make sure. Okay, cool. All right. Okay, so first of all, right, when we're given, so for this example 1, left is equal to and like right is equal to 4, okay? So when we're given left is equal to and right is equal to 4, first of all, what's actually happening here, right? Like if we look at this first linked list and the second one, what actually happens is here, this 3 is going to the 2, and the 4 is going to the 3, and then but you'll notice that that's not all that happens. We don't just reverse this inside part. Another thing that we do is, like, look at this, the 1 goes towards the 4 here, so also this 1 is going to go to the 4, and you can also see at the end of this reversed list, the 2 goes towards the 5. So this 2 goes towards the 5. Okay. So how do we end up with this? Okay. So this is the first part. The first part you're going to do is pretty much reverse the actual list, and the second part is route the node before the left of the list to the right side of the list, and then route the leftmost node in the list, in the reversed list, to the node to the right of the reversed list, okay? So here's how we would go about this. Okay, so if I go ahead and just quickly copy over example 1 here. Okay, here's how I'd go about it, okay? Alright, so the first thing you're going to want to do, right? You're going to want to do this in 3 parts, pretty much. The first thing you want to do is you want to reach the leftmost node of where we're going to start reversing the list, of the leftmost node of the actual portion of the list that we're going to reverse. Okay, so here, like L is equal to 2 and like R is equal to 4, so that means this 2 over here, we want to reach that 2. Okay, so since we want to reach the 2, how are we going to do that? Okay, so to do this, we can use a dummy pointer. What we can do is we can add a node here, it's called D, okay, and we can route dummy to the head of the list, okay? Use a dummy pointer because it just makes everything easier, and you'll see why. Okay, so if we add a dummy pointer and we route that to 1, what we can do from there is we can pretty much Okay. So what we're going to do is we're going to run a for loop. Yeah. We're going to first create a previous. Okay, so previous is going to be equal to dummy, and then current is going to be equal to the head. And we're going to run a for loop pushing previous and current up until current reaches the leftmost of the portion of the list that we want to reverse. So how are we going to do that? The loop is going to run so left, right? We want to like 2. Left minus 1 is pretty much the amount of times we want to run that loop. Because if you look at this, P's here, C's here, and if we run it left minus 1, which is left's equal to, so run it 1 time, then pretty much if we update these values, oops. Well, anyways, if we update these values here, P is going to go there and C is going to go here. So that's what we want to do. We want to do it left minus 1 times, not left times, okay? And the reason we created a dummy is so we could put previous there, okay, and we wouldn't cause an error. So let's go ahead and code it. Let's code the first part. Okay, cool. Okay, so first thing we can do is create a dummy, which is equal to like this node none, and then dummy dot next is equal to like head. Okay, and then what we want to do is, okay, we want to iterate until we reach left, until cur reaches left. Okay, yeah, that's what we want to do, until cur reaches left. Okay, so we're gonna do that. Okay, first we're gonna set cur and previous. So again, like cur is gonna be set to the head and previous is gonna be set to dummy. So we're gonna do prev cur is equal to previous is gonna be equal to dummy, and cur is gonna be equal to head. We're gonna do for I in, okay, so what we can do here is just do that, so it looks a little cleaner, right? So for I in range, left minus 1, pretty much. What we want to do is we want to update these values, right? Previous cur. So previous is going to be equal to cur, and cur is going to be equal to cur dot next. Okay. So every time cur goes up 1, and previous is going to be whatever the cur was previously, before it was iterated upwards. Okay. Okay. So now, after we have this first part established, what are we going to do next? Okay. Yeah. What are we going to do next? So, if I'm here real quick. Yeah. Okay, cool. So, right now, what we established, right? That cur reaches the left of the node and previous is here. So now what we want to do, the next step, is actually reversing the list itself. To do this, we're going to save, the first thing we're going to do is we're always going to save the next node after cur. Okay? So we're going to save that 3 is next node. We're going to put NN here. And what we're going to do is after we save that, we're going to take cur. First, cur, okay, so right now we want cur to go to null because we want to go to null because we don't want the 2 to be routed to the 1 because that's not part of the reversed like list. We want the 2 to go to null. Okay, and then after that, we're going to use the NN value here, and we're going to push C up. Okay, we're going to push C up, and we're going to push P to C. Okay, so previous, cur. And then using that, we're going to route C to actually where previous is. Oh, but I did forget to mention, right? Oh yeah, okay. Right. I did forget to mention what we're actually gonna want to save this point left of the part of the list that we're reversing, right? So we're gonna save this as LP. The reason we're gonna save this point is because like I said in the algorithm at the very beginning of the video of how we're gonna do this, we need to route. You can see 1 gets routed to 4. So we need this node saved so we can route the 1 to the 4 at the very end. That's the second part of the algorithm. So we need to save this, okay? So let's go back to screen 1 here and just make sure. This is not going to be previous. This is going to be left previous. So left of previous. And I'm going to do left previous, right? So, right. So left previous, cur. Okay. But basically, so yeah, that's left previous. And let's go back. We're back. That. Okay, nice. So that's left previous. But since that's left previous, now we're going to have to create a previous variable. And that's where this null comes in. Previous is going to be equal to null. We're going to initialize previous as null. And we're going to route cur to previous. And then after that, we're going to continue the algorithm where previous is equal to cur. So then it'll be equal to 2. And then cur is going to be pushed up to the next node. And then we're going to do cur to previous again. And then we're going to, remember, we're going to have an next node saved. Okay, and then we're going to, push everything up again. Okay. Previous, cur, and then cur to previous again, right? We're going to do that again. And at the very end of this iteration, of all the iterations, basically where cur is going to end up, right, is after we do that, after we route cur to previous, the last thing that's going to happen in all these loops is, since NN would have been here, cur and previous will be pushed up. So cur will go up and previous will be here at 4. Sorry if this looks messy, but let me actually get rid of everything here. It looks very messy, yeah. I don't want to. Okay, so bam, this would be going to null, and this would be going there, and cur would basically be here at the 5, and previous would be at the 4. So basically previous would be the rightmost position in the list at this point, and cur would be 1 to the right. Or previous would be the rightmost position in the actual part of the list that we're reversing, and then cur would be 1 to the right of that. Okay, so this is where we'd be right now. Okay, and now this list would be reversed. However, what you'll notice, what's different about our list, is if the 3 is going to the 2 and the 4 is going to the 3, that's great, right? The 3 is going to the 2 down here, as you can see, right? And then the 4 is going to the 3 down here. That's awesome. But you know what's different? What's still different about our linked list from the result linked list? The 1 is still being routed to the 2, okay? The 1 here is routed to a 4, which is the rightmost side of this reverse linked list. The 2 is still being routed to null in our list. The 2 is routed to a 5, okay? The 2 is routed to the where cur is basically at. So those 2 changes need to be made, okay? Basically, if I draw it out real quick, the 1 needs to go to the 4, and then the 2 needs to go to 5. Okay, 2 needs to go to the 5, and 1 needs to go to the 4. Okay, these 2 changes need to be made to fix this. But let's first code out this first part, the second part of the this algorithm. Okay, cool. Let's code it. Let's do it. Alright. Reverse portion of linked list between like left and right. Okay. So first we want to do previous is equal to null. Okay. Or none, rather, in Python. So I'm going to establish that previous is equal to none, and then what we want to do, right after we establish that previous is equal to none, we want to save. Okay, so how many times are we going to iterate, by the way? So I forgot to mention that, actually. Okay, just want to make sure that I am on the screen. Okay, cool. So how many times is this iteration going to happen? Well, it's going to happen. So if you've ever done like a sliding window problem before, to get the length of a window, you would do right minus left, okay, plus 1. And the same idea applies here. To get the length of a linked list, pretty much. So how many times we want to iterate, which is the between right and left, right? That's how many times, that's how many nodes you want to reverse. It's going to be right minus left plus 1. So that's how many times we're going to be iterating here. Yeah, and that's how the way it is. Okay, cool. So after we establish previous for y in like range of right minus left plus 1, what we want to do every time is first we want to establish next node. So next node is going to be whatever cur is at dot next, right? Next node is the next node after cur. And then we want, okay, yeah. And then after we establish that, then we want cur dot next is equal to previous. Okay, so whatever cur is at should go to previous. And then we want to update previous and cur. So previous cur. So previous is going to be equal to cur, and cur is going to be like next node. Cur is going to be whatever next node is. And that will take care of this portion of like reversing the linked list. Okay. And now we have our last part here. Okay. So let's go ahead and yeah. Nice. So now we're at the very end now. Okay, this is the home run. So what do we have right now, right? We have the 3 goes to the 2. We have the 4 goes to the 3. We have the 2 goes to the null. Great. Okay, let's do the first thing, right? How are we going to get this 1 to go to the 4? Because we need 1 to go to the 4. Okay, so 1 is whatever is directly to the left of the leftmost part of the actual part of the linked list that we're reversing. And if you remember correctly, we're going to have left previous save there, okay? Because we never changed left previous. We pretty much just stopped it there, and we started using a previous. So we saved this position. And also, if you remember, after previous and cur do all their iterations, previous would be here at the 4, at the very end of the part of the linked list we're reversing, and cur would be 1 to the right, okay? So let's keep these in mind, that we have these references basically, right, to these nodes. We need them, and we do need them now, okay? We had them there for a reason. We need them now. Okay, cool. So first of all, we need this 1 to first thing we could do actually is let's take care of this 2, okay? The 2 is going to the null, and we need the 2 routed to whatever is to the right of the actual part of the list that we're reversing. So what we can do is we can pretty much just take lp.next. Basically what that means is lp.next is referencing the next node after left previous, so that would be the 2. And then if you add another .next on top of that and you put an equal sign, we're referencing the actual pointer for this node. So the pointer for this node would be equal to cur, or c, which is conveniently going to be to the right of, conveniently going to be at the node that we want to point to, right? As you can see. So yeah, we're going to do that for that. And then what we're going to do, and then the next thing we're going to do is we need to point the 1, which LP is at the 1. We need to point that to the 4, right? We need to point the 1 to the 4. And previous is at the 4. So we can just put LP to previous. We can point LP to previous. Okay? And then what we can just return is dummy.next, because, okay, like if left was equal to 1, for example, then this 1, or the head, would be getting reversed in the list. So we don't want to return head, because head could get moved around. So we just return dummy.next, because dummy stayed here. So dummy.next would be whatever the head is at after all the reversing and stuff. It's clean. So we can just return dummy.next, and that would be our final answer. So let's code that. All right, bet. Okay. And yeah. All right. So now what we want to do is we're going to point. Okay. So we're gonna point. Yeah. Okay. So we're gonna be pointing whatever is left of leftmost part of versed list to, or let's keep it simple, point left prev to, we want to point left previous to previous, okay? Or yeah, to previous, and we want to point what do we also want to do? We want to point node to right of left previous to C, or cur. Okay, we want to point node to the right of left previous to cur. Okay, so let's do that. Okay, so left previous dot next is equal to previous, and then node to the right of, left previous dot next, just left previous dot next is equal to previous, and node to the right of left previous is left previous dot next is equal to cur. Okay, and then we can pretty much return dummy dot next, because that would be whatever dummy points to, which is, that's the node we're going to return from. Okay, got the wrong answer. Let's see what went wrong, right? We got 145. We expected 14325. How did we get 145? Let's see. 145. It's interesting. Well, let's take a look at our code. Okay. So we set dummy is equal to list node none. Dummy.next is equal to head. Okay. So dummy is pointing to head. Okay, cool. Left previous, and then we set cur, and then left previous is dummy, cool, and then cur is head. That makes sense. We want to iterate until cur reaches left, okay? So we're going to iterate left minus 1 times, and that's going to be left previous is going to be equal to cur every time. Cur is going to be cur.next. It's going to go up. Cool. Reverse portion of linked list between left and right. Previous equal to none. And then we're going to iterate right minus left plus 1 times. It's correct. So next node is whatever is next in cur. Cur.next. Oh, wouldn't it be previous is equal to cur.next? Or no. No, that's right. So whatever currently is at, it's pointing to previous. And then previous and cur get moved up one, right? Previous goes to cur. Cur goes to next node. Cool. Point left previous to previous. So left previous dot next, right? Is going to be pointed to previous. That does make sense to me. And so whatever's next up after left previous, that next node is going to be pointed to cur. And that is going to be pointed to whatever cur is at. Okay. And we return dummy.next. It's interesting. Okay, so iterate until cur reaches left. Let's try printing something here. See if we can figure it out. Okay. Let's print head real quick. See if I get anything. Okay, 1 here points to 4. 4 points to 5. 1, 4, 5. Is dummy not at the beginning of the list? Or did we route something out wrong? I feel like something's like missing from the list straight up, you know? So like, if dummy.next is only returning 3 values, the 3 and the 2 are low-key getting thrown out of the list. So maybe you're doing the reverse portion, something went wrong? Okay, so next node cur.next. It's fine. Cur.next is equal to previous. So then we're routing cur to previous. And then previous and cur are being pushed up one every time. And left previous dot next is previous. And that's cur. It's hard. Maybe print dummy.next while we're doing this. Like the entire time. Yeah, we have 1, 2, 3, 4, 5, and then we only have like 1, 2. Am I doing this wrong? Next node is cur.next. That is referencing the next node. What? And then cur.next equal to previous. Previous is none. That's right. And then previous and cur is right up one. Can't be wrong. Okay. I guess iterate until, let's check if each section is working correctly, right? Iterate until cur reaches left. So if cur really reaches left, then after this, right, if I print cur, then I should get from left onwards, right? That makes sense. Okay. Left is equal to, okay, cool. That's right. That worked perfectly. Okay, and then reverse the portion of the linked list between left and right. Reset previous equal to none. And so technically, if I print dummy.next, it would just be 1 and 2, right? Because 2 goes to null, so it's lost. Like if I print dummy.next here, it should just be a 1 and 2. That makes sense. Okay, cool. What if I print, right, of a 1 and a 2? If I print previous, should be a 4 and a 5. 4, oh, to 3 to 2. Oh, no, not 4 and a 5. 4, 3, 2 is right, yeah. 4, 3, 2 is right. Okay, this looks like it worked correctly, actually. Nah, this definitely worked correctly. I definitely messed up in this last section then. It has to be. That's where the error occurred, yeah. Okay, let's go back to the drawing board then. I'm just going to show you guys my thoughts as I go through this, right? Alright, let's see. I think I'm right about this. Like C would be at 5 and P would be at 4. Right? Yeah. Seems alright. LP would still be at 1. That's correct. Okay. Or, would it? Yeah, it would be left to the okay, cool. Okay, cool. Okay, at this point, the 1 needs to point, or left previous needs to point to P. Needs to point to previous. I did that. and left previous dot next. So whatever's next up has to point to the 5, right? To point to Kurt. It does that. Yeah, it does that. Is that not like... Is that not right? I'm gonna see how this changes every single time. Here. I'm gonna see dummy dot next print it. Or 1 to 2. Technically, right? 1 is to 2. The expected behavior after I do this command, which is left previous dot next equal to previous, would be yeah, that goes to previous, then be 1 4 3 2 1 4 3 2, and finally if I do okay, if I do that 2 to the 5 after that, the 2 goes to cur. Of previous dot. Yo, wait, am I... Oh, hold up. Hold up. If I do left previous dot next is equal to previous, left previous is not pointing to that next node anymore. It's pointing to previous. Left previous dot next is like... Okay. Maybe I should run that first, right? Like, yeah. That doesn't affect, because this, if I change this first, that doesn't affect left previous dot next is equal to previous. Like, but the vice versa is not necessarily true. And that was there. Cool. Okay. Problem solving. Took a long time though. That was kind of pathetic. All right. What is the time complexity here? Well, this is going to be open. Ultimately, we're going to iterate through this entire linked list to do this operation, right? Ultimately, we are doing that. We're iterating through the entire linked list through all these iterations. It's O of n. And the extra space is O of 1 because we're not creating any new structures relative to the input. And that's going to be the answer.